All right. What's up, everybody? It's Ryan here, and you are watching another episode of the show where we combine poor grooming habits and very good information with substandard lighting quality for educational purposes. Thank you for joining me for another Ask a Programmer live thingy. Before I get started here, I have to give some full disclosure. I am moderately underslept. Yesterday was a very busy work day. I ended up doing 9.5 hours of work on coding and writing and everything I do on a day-to-day basis. Also recorded, edited, and published another video on Jetpack Compose. So I might be a little tired today. I might be stumbling over my words, but I am going to do my best. Just for those who aren't aware, here in BC, we had... the video is loading. Oh, what does that mean? Well, I have an excellent connection, so if there's some issues, it's for a change probably on your end, but thank you for letting me know, Harm. It was daylight savings time. That change was last night for people who, like me, who live in British Columbia, Canada. So daylight savings time, for those who don't know, it's this really stupid idea that a whole bunch of people have that we should change our clocks twice a year. And thankfully, I'm not normally happy with my local politicians, but I know the BC Premier is trying to abolish daylight savings time, or at least get us to just stick on that. So anyways, the reason why I told you that little story is because I'm a little underslept today and I had a busy work day. But I'm going to carry on and hopefully we'll have a good episode regardless. Thank you for joining me, Harm. I do appreciate it. And what's up, Lucas? So, I'm going to ramble for a little bit, just until we get maybe a few more viewers, and then I'll get into the main lesson content. However, I can share with you the main lesson for today. This was supposed to be Roboto 20. Zoom in a little. So yeah, I'll just mention what the main topic is for today's episode. So the main thing I wanted to do is I want to combine a topic which I have half a decade of experience, I can't say that, with, and then sort of intermixing that where we're working with Jetpack Compose. So today's episode is about software architecture in general and specific to Jetpack Compose. I've been doing a lot of work with Compose since before beta, since I think about Alpha 7, and I've come to my own conclusions and have my own approaches about how I like to architect my applications when working with composables, and I've got a lot of good things to say about that. But anyways, I'm always happy to talk about software architecture in general. It is actually, there are very few things I will say that I'm really quite good at, and software architecture is one of them. So there's a couple different things. The three things that I'll be covering once we get started, if I can organize my notes, possibly. Let me just fix this up. Okay, that window goes over there. So there's kind of three things we're going to talk about once we get started. Define clean architecture. That's going to be a fun one. That's always a fun one. Demonstrate my architecture in two different ways. So I'm going to show you an image, and then I'm also going to take you through a pattern sequence. Which is basically like I'm going to take you through a whole stream of data through the application. If that sounds technical, I'll just walk you through some code and explain it, is basically what that means. And then open for questions. And after, I'm going to prioritize software architecture questions, but obviously after I'm done rambling about the lesson part, then you can feel free to ask me about whatever you like. Before we get into that lesson, I just wanted to answer a quick relevant question here from Harm. Harm asks, what is Jetpack Compose? So basically, in a nutshell, Jetpack Compose is a way to build UI, user interfaces, in Kotlin for Android and desktop, and they're working on web port. So whereas in Android we used to use the view system, and you could use you could build your UI in Android using Java and Kotlin programmatically, but most of the time we used XML layouts. Jetpack Compose doesn't use any XML. There's a lot of great stuff I can say, but Harm, if you want to learn the basics, I actually have released 2 videos now on my channel. They're some of the more recent videos explaining the basics of the tool. I don't know if you're an Android developer, Harm, but if you are, you definitely want to look into Jetpack Compose, unless you're one of those people that really loves XML. But even then, I think you'll want to check it out. So that's it. Hey, thanks for stopping by. Goedendag. That's my best attempt at speaking Dutch. So, anyways, that's it. I don't know how many viewers we have, but I think I'm going to get started with my lesson for today, and we'll just have to give her, because there's only so much mindless rambling I can do. So, we're going to get started with part number 1. So today's topic is about software architecture in general and specific to Jetpack Compose. Now, before I get into what I'm going to talk about, so I'm going to do something different from a lot of other teachers who talk about software architecture. I'm going to explain things in a way which is probably so simple that you're not even going to believe me that I know what I'm talking about. And that's okay. But I do want to remind you, I am very well studied. This is a weathered copy of Clean Architecture by Robert C. Martin. I first started applying clean architecture principles to Android applications back in 2016. I first started with Android in 2014. I've since come to prefer Martin Fowler slightly over Uncle Bob, but I still have a lot of respect for Uncle Bob as a teacher of good software design. Anyways, I mentioned those 2 names. Let me write them down. So the first thing is, for more resources, look up Robert C. You'll probably know him as Uncle Bob Martin. Let me zoom out a little. That's just that font's a little out of control there. And Martin Fowler. Personally, I prefer Martin Fowler's work. I find him a little more easier to understand. Sometimes Uncle Bob confuses me, but I'm not saying that he's wrong. I'm just saying that sometimes he confuses me. The single responsibility principle in particular from Solid Principles, that's a confusing one, the way he explains it. With that being said, like I say, huge amount of respect for both these individuals. I'm not going to do what they do. Uncle Bob and Martin Fowler, they'll, more so Uncle Bob, he'll give you a whole bunch of definitions and definitions that apply to various perspectives and scales of a software application. That's not what I'm going to do today. I'm going to make it very, very, very simple and teach it the way I teach it. And I don't know many people who do teach it like I teach it. In other words, I'm going to try to be as beginner-friendly as possible, but admitting you're never going to be a good software architect unless you apply these principles for at least a couple years or a couple months in projects you're building. And if you want to ask me about what the point of applying these things is, I can talk about that later. So let's just knock off this first question here. So define clean architecture, and I'm going to define it my way because the truth is Uncle Bob and Martin Fowler don't always use the same words, don't use the same definitions. There's a lot of crossover. But yeah, here we go. So I want you to for the purposes of this episode, if you're a beginner, I want you to think of clean architecture as basically meaning three things. And we're going to look at some code examples to kind of cement these concepts. Some hopefully simple code examples, at least if you understand Kotlin. So the first thing is, number one, and this is the golden principle. These are my words. This is what I call the golden principle of SA, software architecture. Apply separation of concerns. This is the most important thing. If you don't do anything else, this will help you make code which is easier to name, like functions, classes, things like that. They'll be easier to name, they'll be easier to build, they'll be easier to change, they'll be easier to improve, they'll be easier to test if you can just apply this one concept. So what this basically means is, to give like a general definition here, not that I'm a big fan of verbal definitions, but every function, class, or interface should be made as small as reasonable. Now, when I say as reasonable, that is, I'm picking my words carefully there. I'm not saying as small as possible. You will meet people who are hardcore, dry. So dry is an acronym for don't repeat yourself. Enthusiasts. I used to be that person, but many senior developers prefer to apply it only to the degree that it solves more problems than it creates, which is a big fancy way of saying don't over-engineer. But the truth is that you're not actually really going to intuitively know what over-engineering is until you become that person who applies these kinds of principles too much. And that's okay. I think almost every software architect goes through that. And when I say software architect, I mean anyone applying software architecture principles. So this is the most important thing that I recommend. Every function, class, or interface should be made as small as possible, and we can see that in Jetpack Compose. We have like a root composable, and yeah, that one's fairly large, but whenever convenient, I'm breaking things down into smaller and smaller pieces. This is like the root screen, and it swaps out like a loading screen, or a game complete screen, or an active screen, and each of those screens are themselves composables, and I keep breaking things down all the way into like individual widgets, like Sudoku button, a timer thingy. So that's the main. If you don't do anything else well or at all, I suggest you apply separation of concerns. This is also known as modularity. Let's add that word in there. And that's what I recommend. The second thing I would use to define clean architecture, write loosely coupled code. Now, unfortunately for the beginners, this is the kind of thing you need to learn from either my courses. I have courses available on my YouTube channel by subscription, $2.99 a month. You can learn everything I know about software architecture almost in a course with direct examples. Also, I'm on Skillshare. This one's a little more technical. If you're a beginner, I can't easily explain to you what loosely coupled code is, because basically what it means is use interfaces, abstract classes, function types / references, and the observer pattern, to name a few things. There's a lot more to it, but in a more object-oriented world, which is more like a Java, maybe C# type thing, C++ for sure, you're going to want to use constructs like interfaces, abstract classes, those kinds of things, because they loosely couple your code. If class A has a reference to class B, and like knows what class B is. It knows the proper name of class B, the concrete name. That is a tight coupling. If class A knows class B through an interface in the middle, that's loose coupling. If class A has a function reference to class B, which is something we see in more modern languages like Kotlin, that is also loose coupling. And then the observer pattern, which, if you're not sure what that means, live data, RxJava, you can do it with Kotlin Flow. It's actually really, it's not a difficult pattern to write yourself. These things are all the observer pattern, and again, that's a way to achieve loose coupling. Let me give you one code example. Again, it might be a little technical for the beginners. What's an example here? Here we're working in Compose, and the way that I provide data to the various composables, which are like UI elements, is any element that needs some data, I give it a view model, and then what I do is I provide a function. The view model exposes a function reference here, something like this, or function type, excuse me. And then what the composable will do is it'll provide a lambda expression. This is advanced stuff. If you're a beginner, don't worry about it. It'll provide a lambda expression, and what will happen is whenever the view model's data gets updated, it will call that function, and the end result is that the data gets passed into our composable. So we have like a loose coupling. Yes, there is a reference here, a concrete reference to this specific view model, but I'm not concerned about that. I don't actually have any benefit from hiding this thing, in this case, behind an interface. But the net benefit is that instead of the view model calling the view, which these composables are, which wouldn't be MVVM anyways, because view models are not allowed to do that, it just publishes data and the view model just happens to be listening. So yeah. Write loosely coupled code, so that means use interfaces, abstract classes, function types, stuff like that. And then the final one, use tried and true solutions to common problems. So this is patterns, for example. Just one moment, just make sure my stream is working properly. Yep. So use patterns. Now, I don't have time in a short lesson to explain any particular patterns, except to say that one interesting thing is that we can do the observer pattern using like an interface or abstract classes. We can use abstraction. One of the cool things we can do with languages that allow function types like Kotlin, and a function type is exactly what you see here. Here we have a function type definition. So we're saying this, in order to bind to this view model and listen for data, we can do that by providing a function which accepts this as arguments, or this, and returns unit. And this is almost a much simpler way, it's a more functional way to achieve something which is essentially the observer pattern. Depending on how you look at it, it fulfills the same goal as how I would describe it. So again, we're going back to the observer pattern there, but use tried and true solutions to common problems, and this is another way of saying use patterns. So this is how I would generally define clean architecture, is, just to summarize, apply separation of concerns, which is a fancy way of saying don't write giant methods or functions. Don't write giant classes or interfaces or anything like that. Make everything as small as reasonable. However, I do agree that there's a point where you're over-engineering. And you'll be able to tell where that line is just by practicing. So that's that one. Secondly, write loosely coupled code. Again, sort of a more advanced thing here. I can't really explain it simply other than to say use interfaces, abstract classes, things like that. or function types and references, and things like the observer pattern. These all promote loosely coupled code. And then finally, we have use patterns, basically. If you don't do those three things, even if you don't have an interactor or a transaction script or a domain model or an entity or all the different words that Martin Fowler and Uncle Bob use, you're, in my opinion, still applying the principles of clean architecture. And we'll leave, we can talk later about what the benefit of doing that is, but here's how to achieve it. Moving on to number 2, I want to give you a demonstration of my architecture that I use in this particular application. Now, a couple things. I don't follow one single architecture. My architecture adjusts to the project requirements, which is another way of saying that I let the project requirements or the requirements of the specific UI feature or screen that I'm working on tell me what kind of software architecture I should use. In a simple one, sometimes I can get away with just MVP. Sometimes I can get away with MVVM. In a complicated UI, and you know what, my general approach is something like this. I have both a presenter, I call it a logic class, presentation logic, but presenter applies, and a view model. And the view, if I can zoom in here, still observes the view model. So again, the view model is not allowed to have a dependency to the view and nor a dependency to the presenter. The view forwards click events to the presentation logic, and the presentation logic functions as a decision maker. I don't want my view model to be a data container, a data cache, and a decision maker unless there is almost zero decisions to make. And I feel like this is where most people have trouble with model view view model, and it's not their fault. They're told that you can do model view view model and you're not going to need a separate class to handle presentation logic. And if you are in a feature or an application which has complicated presentation logic, I simply don't agree. I prefer to pull it out into a separate class. You can build a giant view model, a thing which is supposed to be modeling the view, so storing the data necessary to render the user interface, full of logic. You can do that and you can call it a view model, but the name view model doesn't make a whole lot of sense when you do that. But I'm not crapping on MVVM specifically. I think it's a great idea. I love the idea of the view observing something like a front-end cache for UI data, and sometimes the presenter gets to ask the view model for data as well, and that's pretty handy instead of having the presenter ask the view for the data, which you can't easily do that in Compose in particular, because of course in Compose we're working with functions, top-level functions. There's a few other elements to this thing. So we have build logic. This is basically dependency injection, service locator type stuff. You don't need to use Hilt or Dagger. You can if you want to. In a small application, I'm going to say pretty bluntly that unless you're practicing to learn how to use Dagger 2 or Hilt or whatever you want to use, then it's totally pointless. It's a waste of time and dex size. You can write the code that these tools will do for you really simply. It's literally just the code required to build things. And you can get all the benefits of dependency injection, or whatever you want to call that, inversion of control, by doing that. However, again, when a project becomes quite large, over time, this kind of code becomes more tedious for the programmer to write, and that's when I do think it's a good idea to look into a framework to handle dependency injection. Not really going to talk about domain model. That's a confused term, but I will point out that I have a domain layer in this application, which is a pretty typical thing you'll see in clean architecture. It holds repository interfaces, but not repository implementations. And these things actually function as use cases in a smaller application. You don't need use cases or interactors or whatever in a small application if all they do is call one single data source, like a database or a retrofit. You can, it's just kind of pointless. Instead, you can use an interface, and in a small, simple application, this will save you time. In a larger application, yes, I do use interactors or use cases or whatever the heck you want to call them. So yeah, you've got that. I've got that stuff going on. And then this is something I just do all the time, a front-end contract interface. And this is actually something that helps me design features. That's not it. I didn't really do it so much in this particular application because it wasn't so necessary. But when I wasn't working in Compose, I tended to use a lot of front-end contract interfaces for the view model, and the presenter. But like I say, in Kotlin with function types, you can be a little less specific about that kind of thing. But I do still have an interface for the activity, which functions as a container. And notice, yes, I am using activities, but I'm not filling them full of code. They've got exactly the kind of thing you would expect a UI container to do. So they set up the composables, they wire up the logic class, although here you can see I've brought the actual logic required to do that into a separate top-level function, which is my sort of handwritten dependency injection type deal. And it's a natural place to create the view model, and I can pass that into the composable. But again, it doesn't really make a lot of decisions. In fact, ideally, it doesn't make any decisions. It just gets told what to do by the logic class. So, the only other thing to point out here, what is the view interaction? In basically every application I've written for a long time, you will find a sealed class or something. In Java, I would use enums wrapped by a class. You'll find a sealed class which for each part of the UI or each primary UI screen, it will model those different interactions using a sealed class. So this is a Sudoku game, pardon me, and I'll take you through an example with it with the emulator if my computer can handle it. This is a Sudoku game, so we have all the different ways in here that the user can interact with the game. Inputting a number, clicking on a tile, when the user wants to start a new game, and also some life cycle events, on start and on stop, which are actually callbacks that the oops, give me the activity. The activity will actually signal those. On start tells the logic class, okay, we're ready to go, get the data, and on stop tells the logic class, okay, time to shut things down. So that's my general approach to architecture. It does change from time to time, and you can use whatever you like. I just hope you're using some kind of an architecture. So what I'm going to do is I'm going to fire up my emulator, and I'm going to take you through a sequence, and that'll basically be the last thing we do before I just open up to general questions. So we're going to fire up the emulator. Let's do, maybe I'll do my, Nexus 5X. That might be a little easier for my computer to deal with. And I'm just going to deploy the application. And my computer might lag a little because Android Studio, Google Chrome, and streaming software is quite a lot for a mid-high range rig that's several years old. Gradle is building. Hey, what's up, Camcol? I'll get to your question in a moment. I just want to try and get through this lesson. Otherwise, I'll be rambling forever. Good old Gradle builds. And while that's loading, what I'm going to do is I'm just going to throw in some break. Actually, I don't think we'll debug. Yeah, I'll just take you through it manually. That's probably a better idea. Apologies for the wait, but, you know, it's Gradle. Okay, that took a little while. Okay, I'm just going to give like a couple seconds to let my CPU cool off. Okay, so here is the application. Now, I see we're starting to get some questions going, so I'm going to go through this pretty quickly, and then we can get started answering the questions. So thank you for asking questions, and I'll get to them shortly. So I just want to take everybody through the architecture. So somebody, of course I had to close the, here, just give me 1 second. Okay, so one person in the chat, who is it? I'll call you Loud. Oh, sorry, I'm in webcam mode. Said you're using MVP. Why not MVVM? I'm using neither MVP nor MVVM. But let me answer that in detail in a minute. But I'm not using MVP. That's not accurate. I'm using neither. Okay, so let me just take everybody through a really quick sequence here, a pattern sequence. I've been listening to Douglas Schmidt a lot, and he's given me some new vocabulary terms, which I like. So I'm going to take you through an interaction with this application. So I'm going to interact, and then I'm going to show you kind of like a debugger if you set breakpoints, what is actually happening. So when this thing fired up, when this app launched, active game activity started. And then we set the content to be active game screen. And we passed in a view model. And then we also set up a presentation logic class. Keep that image that I, like a friggin' idiot, X'd out again, which was stupid, but whatever. Yeah, so I'm gonna mouse wheel click on active game screen, and that's gonna take me there. I am taxing my computer pretty hard here. Okay. So what we're going to do is, so here my composables are going to correspond. There's a bird outside like having a a seizure or something. That's just a really bizarre sight. Sorry, that was distracting. I live out in the country, and sometimes you see animals doing weird stuff. So we've got our composable here. This composable represents this whole screen, but obviously I've applied separation of concerns, which I explained earlier in the episode. What's up, Nikhil? And so I'm breaking the UI into individual parts. So there's a loading screen, and what you see here is what I call the active game screen state, or active game content. So we'll head into that. Game complete, or sorry, wrong one. I mean this one, active game content. So I'm going to go in here, and then this part of the UI represents the board, the timer, the difficulty display, let me zoom out a little, and the input buttons. And obviously each of those things I have broken down into individual components. We've got the input buttons, the timer text, we've got the board itself. I do even break the individual text fields down, and this is where we're going to start with our pattern sequence. So what's going to happen is I'm going to click on one of the squares. Let me see if I can find one. I'll have to do some Sudoku for a second here. I think that, yeah, this is a medium puzzle. Let's see. Okay, so I know there needs to be an 8 here. So I'm going to click on this tile, and notice how it's highlighted. So what actually happened there? So to take you through what happened, each of these Sudoku text fields has a clickable modifier on it, and it invokes ActiveGameEvent.onTileFocused. So that's what you see here. This is just a sealed class. I'm going to go through this kind of quick, but I wrote an article explaining exactly what's going on here, so I'll see if I can remember. But you need to follow me on Twitter and Free Code Camp and YouTube if you want to learn, or if you want to follow my content. But so I clicked a button, and then that triggered this onEvent handler, this onClick function here. And onEvent handler itself is a function type, and we'll see what that thing actually is in a moment. So we created a sealed class event to represent that particular event. So I need to know what is the x and y coordinate of the square that was clicked. In this case, it would be x0 and x8 and y0, or x9 and y1. I can't remember if I started at zero-based indexing or not, but one of those. So that's just a sealed class, and what happens is the presenter, which is the active game logic, will receive that. So behind the scenes, and this is our loose coupling, this function type here, onEvent handler, which accepts an active game event, is actually concretely my presenter. And you'll notice that it has a function called onEvent. It doesn't have to have the same name, but it does have to have the same parameters and return type. And so this thing will actually unpack that event and decide what to do with it. I won't take you through the whole thing here, but it received an onTileFocused. Let's jump there. OnTileFocused updated the view model, which has this focused state somewhere. Where is focused state? Update focused state. So, and that updated the state of the board, the state of the puzzle board here. And when focus is true, then the composable, when we jump back into that, let's go active game screen. When the composable receives that event, which it will receive in the, it actually receives it upstream because I have to redraw the whole board for the time being. I might be able to fix that later, but for now, it receives that event. Where is board state? Somewhere here. Game content is complete. Somewhere. Sudoku board. Right. So it receives it here. So I'm only redrawing the Sudoku board. And what happens is it will then redraw this part of the UI with that particular tile focused. Okay. So that was number one, and then I'll just do one more sequence where we input a button. So because I'm a Sudoku wizard at this point, because I've had to spend a lot of time solving Sudokus and thinking about them in order to model them as graph data structures, I know an 8, I was joking there, I'm not that arrogant. I know an 8 needs to go there. So I've selected that tile, and then I'm going to hit 8. Now, what that did is, in this particular, where's the actual button here? Right, it was an input button. Where are my input buttons? So I clicked an input button, and then again we have that same function type here which accepts our event sealed class, and it fired the event on input. So that's what that was. If I scroll up, you can see an 8 is now there, and what happened is, again, that event got passed to the logic class. The logic class unpacked that event, so it got what number I clicked on, which was an 8. And also, I don't remember why time or state is there. Who cares? Oh, I need to, every time I update the state of the Sudoku game, I need to update it in the back end. That's why it's there. So first we update it in the view model. So what I'm doing here is I'm checking all of the different values in the view model to find which tile is focused. So in this case, it was that one. And then I know that's what the user wants to input. Then I try to update the backend. If the backend successfully gets updated, then we update the board state. It'll redraw the thing with an 8, and then we're good to go. If it fails, then we show an error, basically, and we don't update the view model or anything like that. So that's basically how this kind of thing works. I think I'm going to shut up here because I've been talking a long time, and we will get to some questions. But I hope that was kind of a useful thing for you to have a look at. And yeah, so that is one example of a pattern sequence, a data stream, depending on how you look at it, of my architecture. And now I will get to Q&A after I drink some coffee. So yeah, that was fun. That was a classic Ryan move there. I'm like, I'm not going to talk for very long. And then it's like, yeah, 45 minutes later, I'm done giving my lesson. Okay. So now we start to check quest. That was a very terrible Brazilian accent, in case you were wondering where that was coming from. So let's get started from the top here. All right, so we got a question from Camcol. That's a great name. It sounds like some kind of like something that happened to your ankle or something. I don't know. I've got Camcols. Okay. Hi, Ryan. Do you think Jetpack Compose requires to write Android instrumentation tests with emulator to fully test logic and behavior? At the moment, absolutely. So let me see. I have to be a little careful looking up web pages with my bandwidth here, but so I'm not going to give a detailed answer here, but basically the Android team is working on improving testing for, like they say it right here, testing is an integral part of the API surface of Compose, currently in development. So we don't have an easy way to test things. I actually tried writing, you've got some options here about testing things. I couldn't really get them to work with my rig, which was kind of depressing. I'm not sure exactly what was going on, but it's difficult to write tests at the moment. And that means, yes, I have absolutely had to test either with an emulator or with my phone in order to verify the logic and behavior of my composables. I've never been a huge fan of espresso testing, for the reason that I partly solve that problem by applying the humble object pattern, or the passive view pattern, which is a fancy way of saying I don't fill my views full of logic, so it's easy for me to know if they're broken or not. But with that being said, I hope we do get to the point where maybe in the Android preview, like the design preview of Compose, which doesn't use the emulator, maybe if we, I don't know if that's even possible, but if we could write some kind of tests there or something like that, that would be really cool. So my answer there is, at the moment, my experience so far has been that testing with Compose, like Compose itself, is under development, and it's a little early to, in my opinion, you can play around with the stuff, but I think it's going to get a lot better. At the moment, yeah, absolutely, I've been using heavy instrumentation tests. And for those who aren't sure, actually, Camco will explain it right here. An instrument is, in this context, is another word for a device. Instrument is like a really old school word to describe a device, but you can use that word in English. It's a device test, and you could use an emulator or a physical device. So that's what that means. So let's get back. Let me just close this window. All right. Next question. All right, this is from, I'm going to call you Loud. Hi, Ryan. Do you think Jetpack Compose... Oh, sorry. I thought I copied. Let's try that again. Hello, I just joined now. Are you... Oh, you wrote, are you using MVP? Why not MVP for this game? So, let me, again, because I just habitually close windows, I closed my diagram, my image again. So let me just pull that up. And there's a lot to go into here. So, oh, sorry, I'm in blocked mode. I don't use MVP or MVVM typically. In very, very simple features, like a login screen, I might use just MVVM. But for the most part, anytime I have significant presentation logic, I will have a presenter handle that presentation logic. I do not agree that you should fill your view model full of presentation logic, and MVVM, the pattern itself, does not eliminate presentation logic. And what you will see is that you'll see people who have this thing called view model, and it does what the name implies. It models the data necessary to draw the view, but it's also full of presentation logic. So you get this big ugly blob of a class which does probably a lot more than any one thing one class should do. In small applications, you can get away with doing that. In medium-sized applications, you can get away with doing that. There's a point where, even in, I think, just medium or larger applications or UI features, it makes sense to me to add in a presentation logic. Let me kind of show you what I mean. So in this application, the let me pull it up again. So effectively, the view in this diagram is the composables, are the composables. So that's what the view is here. They communicate with the presentation logic using these function type references. Very important, very useful pattern for Compose. Let me pause for a minute and repeat that. If you are writing Compose or plan to learn about Kotlin's function types, they're not actually that complicated. It's a lot like just a class reference, except it points to a particular function. What function does it point to? Again, I just went through this with everybody, but in case you're just joining, it points to this function here. And so this is representative of this arrow, view to presentation logic. Now, why I have a presenter is you can see there's quite a lot of presentation logic. This is not a small little class here. This is a class which makes a lot of decisions about the user interface. So for me to take all of this stuff and then just slap it into the view model, which itself is not tiny, but it only does what you would expect a view model to do. It holds the state necessary to render the view, and it publishes updates to any view which happens to be listening, which is why I'm using a nullable here. It doesn't know if anything's connected, but if anything is connected, it will receive an update. So that represents this arrow here. This little eyeball thing is my way of demonstrating the observer pattern. This is my own UML notation. So the presenter tells the view model what to do. It sort of updates the view model. The view model stores the data, and then it publishes that data to the composables, because each composable that needs data published to it is given a view model, and it's given a remember delegate. This is a little technical, so I'm not going to explain that part, but this is kind of how you watch for changes in state within a composable, but that's kind of an advanced topic. So this is a really important point here. I'm not using MVP, I'm not using MVVM. If you want to call it MVPVM, fine, I don't really care. I call it applied separation of concerns, applied clean architecture. I'm just looking at my code and saying, I only want the view to render things on the screen. I only want my presenter to make decisions about how to render things on the screen, and also updating the backend. A decision maker class, essentially. And then I only want the view to hold and then publish updates to the UI, but it doesn't do it directly. So this is still the same observer pattern here. The view model does not possess a reference to the view. It exposes function references, which are these things here, and this is how the view listens to things, listens to the changes in the UI. And that's how I get this timer down here to constantly update. The UI is constantly listening to that particular function. Or sorry, I should phrase it like the view model is constantly publishing updates to the timer state. And when we look in the screen, if I can find the timer widget, as you can see, the composable gives that reference, binds a lambda expression to that reference. So effectively, when the view model calls invoke on the timer state, what is exactly happening is that it's jumping into this line of code. And then timer state, which is a remembered delegate, the state of that thing changes, and then compose knows to redraw this part of the UI because the state changed, and that's how you get a timer. One example. So I ramble for quite a bit, but hopefully I'm trying to really educate people on how to do that kind of thing in Compose, because it's really important to get that kind of stuff right. And it's easy if you've been working with Kotlin for a long time, but not everybody has. All right. Just Vladislav, what's up, man? Good to see you. Says such naming as presentation logic can be confusing. I usually call this a mediator. I see where you're coming from. I call it a logic class or a decision maker. If I called this a mediator, then I wouldn't really be comfortable having it make like logical decisions at the same time. It would more just be like a router or something that directs the flow of data. And that is part of what it does, but that's okay. Everyone has their own way of kind of naming these things, and it's good to listen to different approaches. I'm kind of with you though. I don't like the name presenter, because presenter is like a shorthand version of presentation logic. And when I look at what this class does, it's full of logic. So that's my particular preference, but it's, it's not a right or wrong thing. Okay, let's move on. So that answers Loud's question. Lucas asks, isn't MVI just MVVM with unidirectional data flow? Well, let me riff on that for a bit. And there's two things. So number one, there is no single MVVM pattern, and you might think I'm wrong about that. That's okay. There's actually a lot of different ways to do MVVM. I wrote an article which breaks down two of these primary ways to do it. So for that specific reason, I'm not comfortable saying that MVI is just MVVM with unidirectional data flow. Certainly MVI has characteristics which are shared with MVVM, and I haven't spent a lot of time working with MVI. I just do my own thing these days, but I am aware that unidirectional data flow is an aspect of MVI. I don't care as I like most of my data flow in my applications will be unidirectional, but I don't follow that principle blindly. The only part of my application which isn't unidirectional is the presentation logic, and in my opinion there's nothing wrong with doing that as long as you test your presentation logic, as long as you test it to make sure it works properly. And the nice thing about having a logic class which has no third-party libraries and no Android platform libraries is that it's very easy to test. You can test it using, you don't even need JUnit, but probably you would still want to use JUnit. That's all you need, and you can write your unit tests. You don't need Espresso, you don't need to mock a whole bunch of stuff. You can if you want. So yeah, I'm not going to go into detail because, like I say, I don't do MVI, and it's the one pattern which I don't have a ton of experience with. I've learned about it, but until I actually apply it in a project, which I don't really have a need to at the moment, it's not really on my radar. It's one final thing I'll point out there. Patterns like Viper or MVI are a great way to understand that looking at GUI architectures only through the lens of 3 layers is often nothing more than a useful generalization. MVVM, MVP, these are generalizations. And it took me a lot of years to understand that there's elements of each of them that you should pick and choose, and then learn to take what you like from each approach, and learn when each approach, such as MVP or MVVM, doesn't work for a particular situation. And this is really important. And that just comes with experience. But don't be dogmatic. Don't be one of those people who... I hear so many people, MVVM is best because Android team said so and they are smart. Okay, so for the people who believe this, important point here, the Android team did not say that. They recommended MVVM architecture, but if you dig deep, you will know that they even said that there isn't one way to do it. They're in, I think it's Android developers backstage. I think it was Yeet Boyar and Chet Haas talked about MVVM pattern and when they adopted it, and they say in that very episode that there wasn't one single way to do MVVM. So they recommend it, and the reason why I think they recommend it is because they want you to not build God classes. They don't want you to just have one activity full of everything that goes into MVVM. They never said that MVVM is the best architecture. Never said that. I've never said MVP is the best architecture. Don't be dogmatic. Don't be dogmatic. Yeah, anyways, let's move on. Oh, this is a fun question. Kureshi asks, how can I gain confidence in Android development? Let me drink some coffee and we'll do a little storytelling from years past. And stick around, Sultan. I'll get to your question shortly. So, I first started Android development back in 2014, June 2014. I had a little bit of experience with Java, but I was still a terrible programmer. I had a lot of trouble learning my first programming language. At this stage in my career, I can competently write in nearly 10 programming languages, but the truth about that is that after a couple of years, you will just start picking up new languages pretty quickly. They're all actually pretty similar. The only main differences like declarative and imperative, those can be pretty different, but a language like Kotlin has a lot of those different features. So I want to remind you, you might look at me, or maybe this is what I used to do. I would look at people writing all this complicated stuff and using advanced language features and architectures. I didn't start out like that, my friend. I started out really sucking. I had no idea what software architecture was. I could barely write Java to save my life, and I just dove into Android not knowing what I was getting into. So I say that because if you're a beginner, it's important not to compare yourself to other people, because that can be very discouraging. So you said, how can I gain confidence in Android? The first thing is be patient with yourself. Be careful not to compare yourself with people who've been doing it for nearly a decade. You can look up to them. I'm not saying you should look up to me, but that's the first thing. Be patient. Number one, write apps even if they suck. This is really important. Don't spend all of your time reading articles about code or videos about code, but write code /apps. You can spend some of your time reading articles and watching videos. I like code along style, so like code along videos, I like those. Or Code Labs. Look up Google Code Labs. This is very, very good. Google Code Labs. The most important thing, my friend, is write code. It took me about 2 years to feel comfortable writing Android code. Now, when I say that, you might be scared because you might think I'm telling you it's going to take 2 years before you're confident. The reason why it took me 2 years is because I was working a full-time job while learning to code on the side. So I could not learn Android full-time. I had to do 2 hours here and there for about 2 years. So this is an important thing. Do expect it to take a few months at least. So like I would say 6 to 24 months if you have no other experience or limited experience writing code. So, all right. Hopefully that kind of gives you an answer here, Kureshi. Be patient. Write apps. This is really important. Write code. Code along videos or Google Code Labs are good because you're learning and you're writing code at the same time. Again, be patient depending on what your life situation is. You might only be able to do like 10 hours of practice a week. And if that's the case, it could take you a long time. And that's basically what you have to do. And then the final thing I have to say to you is don't give up. This is the one thing I always did right. And this is why I am here today, is that even though I am a white trash kid who grew up in a trailer park, a trailer, in a dysfunctional family, and I have no degrees in anything, I'm here teaching people about how to write code and build applications and software engineering and software architecture because I didn't give up. And let me tell you, I wanted to give up so many times because life threw a lot of crap at me. Don't give up, man. Unless you hate it. If you find yourself hating coding, I'm not saying do it anyways. But yeah, that's what I had to do. Okay. Another beginner question. Can you give me dialer pad layout? I don't think I can, Anuj. That's not really what this show is about. Okay. Sultan asks, hi, I'm a new Android developer. I have no idea where to start. A lot of info on the internet. Okay, great. Sultan, I want to ask, do you have any prior experience writing code? Or are you like starting 100% beginner? Because that will change my answer here. So I'll just wait for your answer there, hopefully. All right, I'll wait a little bit, and then if I don't get an answer there, then I'm just going to start answering. There's a bit of a delay. Okay, well, I'm just going to start answering. HTML, CSS. Okay, great. So Sultan has a little bit of experience. So here's how I suggest you get started. So first thing, step number one, download Android Studio. You basically must, oh sorry, I'm in full screen mode. Download Android Studio. You basically must use this. You can set up IntelliJ IDEA, but I've used Eclipse before. I've used a lot of IDEs. I have nearly a decade of experience. Believe me when I tell you, you almost definitely want to use Android Studio. If you don't have a computer that can run that, that is an obstacle for you, because it's going to be very difficult. One thing that's come up lately is, what's it called? Can people in the chat help me out with this? JetBrains, what's it called? It's a way to use Android Studio remotely. Hopefully the people in the chat know what I'm talking about. It's been blowing up on Twitter here. But yeah, I'll answer that in a question. Second, build a hello world. So this is like the simplest app you can make. Just a hello world. Third, build a calculator. JetBrains projector. Thank you, Cybershark. I appreciate that. If you can't run Android Studio, you might be able to use JetBrains projector. I'll explain these steps in more detail in a moment, but I'm just going to lay them out. Build a calculator. Okay. Fourth step. Build something you want to build. Okay, so let me explain how I suggest we go through this. Okay, so step number 1 is simply make it so that you can practice Android development. So this is your first obstacle. Set up some kind of situation where you can practice Android. Secondly, learn how to deploy, so that means run, the simplest Android app you can. So this is equivalent to like your first HTML CSS page. Like maybe you made an HTML page like, I don't know, head, something like head, body. I kind of suck at HTML, so forgive me. But like hi. It's literally like the equivalent of writing a web page like that, but you want to learn how to deploy it. In order to deploy it, you will either need an emulator like I have here, or you will need an Android device. One of these two. And again, this is really important. This is something you're going to need to do, at least eventually. Next, we have build a calculator. Why a calculator? It is a simple app, but it teaches you basic user interactions. So your user clicks on buttons, like I'll show you. Here's a Sudoku app. Don't do Sudoku. It's, oh, sorry, I'm in full screen mode. My apologies. Let me just show what I wrote there. For the calculator, I'm not sure if I was able to see that. My bad. Flutter is just the best. Yep. Oh, I got some things to say to you, Ion, but let's move on in a second. Yeah, Udemy courses, not the best way to get started, but okay. So, sorry, I got sidetracked there. So, do a hello world, which is equivalent to like building your first web page, essentially. Build a calculator because it's simple. Do it because it's simple. You don't want to build a complicated app. You want to learn Android. Building a complicated app and learning Android are two different problems. It'll teach you basic user interaction. So how to handle click events, how to handle the user interacting with your application is really important. And it's a simple app. And then finally, something you want to build. When I started with Android in 2014, I built a workout logging program, like a workout journal, let's call it a workout journal program, because I like working out. So I built a project which was more complicated than a calculator, but it was something I wanted to build and use. Why? Because if it's something you want to build and use, then your motivation to build it will be stronger, and you'll be thinking, what is it like as the user of this application? And as you build this application, you'll start to see, I kind of want to add this feature, or I could improve it this way. So that's kind of step 4. Now, let's talk about learning resources. I have no idea where to start. A lot of info on the internet. So let me think of a good learning resource. So first, Google Code Labs for Android practice. Now, actually, I'm not going to say that's the first thing. What's a good basic introduction to Android? You can learn it from me if you want to. So in both my YouTube channel, for $2.99 a month, you can get my introduction to Android with Android Studio. That might work. I also have that available on Skillshare. If for some reason you can't afford my YouTube subscription for $2.99 a month, and I understand there's people out there who can't afford that, I can send you a free link on Skillshare. So that's an option. If you already have an account with Skillshare, I'll have to send you the free link. Otherwise, I can send you one which still gives me $10, but you get a 2-month 2-month free subscription. But if you already have Skillshare, I can send you the free link. But yeah, I'm trying to think. It's hard to find really good introductory resources for absolute beginners, but Google Code Labs are great. Second, find open source code projects which are similar to what you want to build. So what would be an example here? If you want to learn to build a calculator from me, for example, let me go to my GitHub. Am I in full screen mode? No, I'm not. Okay, good. If you want to learn from me, you could, for example, visit. I'm a bit of an advanced developer, so you'll see a lot of stuff in here which might be a little complicated, but let me paste that into the comments as a resource. And find open source code projects. So code on the internet which is similar to what you want to build. And what you can do is you can let that guide you. This is the best way to learn code for me, is to find open source working code projects and to learn from it, to base my code off of that. And if it's open source, you're not stealing it. That's why it's open source. We share things as a community. And then third, sure, find a good Udemy /Skillshare /free code camp /whatever course to introduce the basics. I want to address something that Ion said, and I'm sorry, I don't mean to attack you or anything, Ion. This is really important. Most Udemy courses suck. Most of them suck. So do not buy a build 99 shitty, awful God activities courses, because people who make those things, most of them are crappy programmers, because if you're teaching people to build God activities and just awful code, then and you're profiting off that, then you're kind of a crappy person. So don't do those build 99 crappy God activity courses. Find one which teaches you to build 1 or 2 well-built, simple apps. They do this specifically because you read this and you think, oh, they must be giving me so much good information. And they're just taking advantage of what beginners don't understand. Some Udemy courses are good. Just be really careful. Gen2 asks, do I have any courses for intermediates? Yes, I do. All right. Look, normally I don't sell things because I hate selling things to people. I guess because it's relevant to this question, let me go through some of the stuff I have available if you want to learn from me. I do put a lot of effort into my courses, and I don't do the 99 crappy. I show you how to build simple but well-built code and applications. From my resources, so I have all kinds of courses for Kotlin/Android from beginner to intermediate, available on my YouTube channel via subscription, or my Skillshare account. So I don't know if I have links in the description box. Let me check on that. I don't know, it might take a minute for me to actually figure out if I have those links there. Okay, it doesn't look like I do. Let me just... Okay, if you want to learn from me, then you can check this out. All right, so anyways, moving on. Sorry, my windows are all messed up now. So I've got all kinds of courses for beginner to intermediate developers. I've got so much content, I don't even really know where to start. But check out my YouTube channel. If you want to get a subscription for $2.99 a month, you'll get access to basically all my courses. I'm in the process of uploading my Kotlin courses to my YouTube channel, and everything is on Skillshare. I'm active on Free Code Camp, so I've got lots of free articles on there. I've got lots of Medium articles. Anyways, I could go on forever, but I do have courses out there. I should make like a video which catalogs all these different things. I'm going to move on to another question. Okay. This is an interesting question from Gustavo. So Gustavo says, why use Android native when you have technologies like React, Flutter, etc. that can do both work for iOS and Android? So very simple, trade-offs. Very simple, trade-offs. So what does that mean? A solution for all platforms will have unique, how can I put this? A solution for all platforms will never be as performant or suitable for every platform. A solution for one platform doesn't work on all platforms. So what am I actually saying here? So I'm not saying use Android native. I'm not saying use React or Flutter. What I am saying here is that this decision is a value judgment based on project requirements. So what does this mean? You need to make your own decision based on what kind of app you're building. So really simply put, Flutter and React / React, like React Native, are okay for some apps, but they present problems when you need to interact with the device in complex or low-level ways. So a multi-platform solution, by way of the fact that it's trying to account for very different platforms, which is basically impossible because these platforms are always changing, and it's incredibly difficult to get one thing to work the same way on multiple platforms. You can kind of do that, and so in some applications you certainly can use Flutter and React Native. But what the Flutter and React Native people who are trying to sell it to you won't tell you is that React Native can have huge problems on Android. There's some things you really can't do easily at all, and it doesn't work very well on Android. I'm not an iOS developer, so I can't speak for iOS, but certainly on Android. Flutter's current, and when I say current, that's as of right now, web interoperability is not great. That's an important point here. Maybe eventually it'll get better. And even at the moment, people are complaining a lot about Flutter's jankiness with iOS. Now, I don't use Flutter and I'm not an iOS developer. I do have a lot of people who I know and work with who use Flutter, and they're telling me, that's where this information is coming from, that Flutter's web interoperability, which was mainly what I was looking at, is not great right now. Unfortunately, I don't think there is a solution which is great for web and mobile. We've got Flutter, React slash native, like, you know, both. Let's just call it React. We've got Kotlin, multi-platform. You've got a lot of different solutions competing for sort of the holy grail of interoperability, but the truth is that none of these things come without negative trade-offs. So what I would say to you is, if you're building a simple application which doesn't need to interact with a lot of system services for an Android device or an iOS device, it's just something simple. It's mostly like downloading data from a REST adapter or something like that. Probably you can get away with React and Flutter, or React or Flutter or Kotlin multi-platform or whatever you want to use. If you're building a really complicated app which needs to do a lot of work with the device itself, and then other situations, some more complicated user interface stuff, that's when you're going to have a lot more luck with Android native or writing native code. Obviously, the problem is if you go that route, the negative trade-off is that you will lose the shared code base across different applications. There's some ways you can mitigate that. Like I could build, you know, I could have a lot of the application on the cloud and then the iOS native front end and an Android front end. But you're not going to be able to share everything like you would with a multi-platform assessment. So really what I'm saying here is that don't fall into the trap of shallow thinking that any one approach is the best approach. Pretty much when people tell you the best approach, what they're telling you is, this is my favorite thing. But this is true of almost anything in life. It's true of a lot of software architecture concepts. What will be the best approach depends on project requirements. It depends on what you're building, simply put. Hopefully that kind of answers your question. All right. CyberShark, our resident grasp data structure expert. Sorry, I'm never going to let you live that down. I'm not even sure if I spelled that right. Okay, so CyberShark asks, how do I finish my unfinished projects? New Year's resolution has been a fail so far due to work and classes. Ooh, that's tough. The only thing I can really tell you here, my friend, is you need to do this kind of work during the period where you are most likely to get any kind of work done. So for me, that would be the morning. If I had unfinished projects and I really wanted to get them done, I would work on them maybe an hour or two before work or before classes. Maybe you're one of those people whose most productive period of the day is like 12 o'clock, like midnight. I'm not. If you are, that would be your time. Now, the thing about this is, if you are really busy with work and classes, then maybe now isn't a good time to work on those unfinished projects. I know I'm not trying to discourage you, but one thing I've learned a lot, especially in the past 2 years, don't push yourself harder than you can manage. And don't get me wrong, I'm a huge David Goggins fan. On another day you'll hear me say, work as hard as you possibly can and work hard for 10 years and all this kind of stuff. And that's half the picture. The other half of the picture is, if I try to be better than I can be, if I try to do more than I can do, then I'm going to get pissed off because I can't match my unrealistic expectations about how much work I should be doing. So really what I'm saying here is, if you can, see if you can adjust your policy, your routine to fit that work in during the time when you're most motivated to get the work done. You're probably not going to be able to work on unfinished projects if you don't really want to at the end of a long work day. But again, it depends on how you feel about those kinds of things. That's kind of my advice. But at the same time, don't, if you're busy with work and classes, it's okay to have a bit of spare time, my friend. Okay. Holy crap, the comments blew up. That's a great, let me just share a comment from Lucas. This goes to what I said before. That's a very succinct way of putting it, just regarding our previous question. From what I've read, native apps acquire all possible advantages of the device and operating system's features. That's true. That's a very good way of putting that. This is the benefit of native apps. The drawback is losing code reuse. So it's really just what is more important to you for the project you're building. Is getting those advantages more important? Is code reuse more important? And it depends on the app you're building. So Ion comments, the course is mostly to get familiar with the platform, not to learn the architecture. For the architecture, I would suggest to learn solid principles and read a design patterns book. So I don't teach that way, and I don't think that's really the best way to learn. So I suffered for many years. I was that guy who took early Udemy courses and looked at early programming teachers who taught me countless bad habits. And that's how the problem is, if you're a beginner and someone who's a teacher tells you to build 99 God activities, you're going to actually think that's how you should write code. That's how you should do architecture. And that's why I don't actually really agree with your statement. I do agree that you can specialize in software architecture and that you should have later on, you should learn design patterns. I'm a huge fan of design patterns. I literally have books on my desk at all times about design patterns or clean architecture. So I know what I'm talking about with clean architecture and patterns. But I don't think you should teach people to write crappy code if they don't understand that what you're trying to do is show them parts of the platform. That's why I personally, when you take my courses, I will teach you things incrementally. By the time we learn the basics of the language I'm teaching you, immediately when we get into building really simple projects and apps, I will immediately introduce in simple ways separation of concerns. I will not teach you how to build God activities or God classes or anything like that, or giant methods. I don't think anyone should teach beginners to do that for any reason. That's my personal opinion. Because like I say, I had to unlearn a lot of really bad habits from teachers who did that. And the important thing is, a beginner is not going to know that these are bad habits that will cause you to build unmaintainable applications. And the first application I built, my workout log application, I had to rebuild it 3 times from scratch. And the reason why is that if you don't learn basic principles of software architecture, even as a beginner, and I mean basic principles. You don't have to read clean architecture cover to cover. Just basic stuff like what I taught in the beginning of this lesson, then you will immediately gain the benefits. You'll avoid a lot of problems that I went through. Because when you don't follow any architecture principles and you just build an ugly blob of spaghetti code, what you'll learn is that that thing becomes unmaintainable, and then you'll have to rebuild it. And it's useful to do that once or twice because you know what happens when you don't apply those principles, but it's not a sustainable way. So, but Ion, I do appreciate you commenting, and please don't take this personally, and I'm not trying to say that I'm right here. That's been my experience. I do appreciate you participating, and hopefully you don't get upset. Made India says, Ryan, please make a Jetpack course in Udemy. I'm kind of the wrong guy to ask about a Jetpack course. So I use Jetpack Compose, but that's just about the only Jetpack library that I typically use. I know Florian from Coding in Flow has a really good course that he just made with Gabor Virati, who is an incredible programmer. And obviously Florian is a very good content creator and a good programmer in his own right. There's a heavy price tag on that course, but I don't often recommend other people's stuff, and I know that course would be a great way because they cover a lot of stuff in there about Jetpack libraries. Just to explain what I'm talking about here, when you look at my code, you'll see my view model does not extend Android view model. It's a class I write. You'll see from like my logic class, you'll never find any Android system, Android platform classes. I don't use live data. I don't use the paging library. I don't use a lot of Android Jetpack libraries. There's a reason why I don't do that, but I think I'll just move on to the next question. And if someone wants to know why I don't really use them, then I can explain it. However, do expect an Android course which includes Jetpack Compose soon when I can work on it. I will give courses on that. Okay. So there's a lot of comments and questions, so I'm going to be maybe a little pickier here. Okay. What's up, Vivek? Thanks for joining me. Gentoo comments, I've started with Flutter, but at the end of that want native features, you have to use plugins. Sometimes you have to do it yourself. For that reason, I've moved to native. Just sharing that comment. You know, people, don't be dogmatic. If somebody tells you that Flutter is the best thing for every situation, that person is either a little bit confused or hasn't actually tried a lot of different platforms and programming languages. If someone tells you native is 100% the best solution, don't use Flutter, then that person probably hasn't tried Flutter or React or Kotlin multi-platform. Don't be dogmatic. I'm not telling you don't use Flutter. I disagree with anyone who says Flutter is the best thing ever. It's not, and I think over time you'll see that due to the law or the nature of Turing completeness, which essentially means that at the low level, all of these different programming languages compile to machine language. So essentially it's just different ways of telling computers the same basic set of instructions. You can learn about that if you study the basics of computation. At the end of the day, every one of these things you pick will be good in some situations, bad in some situations, and you can figure that out by examining your project requirements. Don't get dogmatic. Don't be religious. Don't have blind faith about any one particular approach. Keep your mind open. If you want to know if Flutter is better than native, build something in native and then build it in Flutter, something not simple, and then you'll be able to see, okay, I liked this about the Flutter approach in that app. I like this about the native approach. It's never just one thing. So I'm not discouraging people from using Flutter, but I'm not going to be told that Flutter is the best thing, because it's just not. I know people who are great Flutter developers, and they tell me about certain things that it doesn't do very well versus native. Obviously because I haven't used Flutter, I'm not going to spend a lot of time talking about it. But please don't be dogmatic, people. Be open-minded. Try things before you assume that they're the best. Okay. Let's see here. Graph Sensei. Oh man, I love you guys. We got a flamer here. Somebody who shares my last name called me a nerd. Well, you know what, Richard K? I got one thing to say to you. Idien nachoy. Now, hopefully I don't get demonetized for that. But thanks for stopping by, Richard. All right. Thanks for the insight. Yep, our plugins. Sujoy asks, are plugins really a big problem in Flutter? Maybe someone else in the chat can answer that. I don't know. Sanchit. Sanchit asks, are there a good amount of jobs in Canada for web developer? Yes, Canada has a huge tech sector. Absolutely. Sanchit asks as well, how to identify which Android version we are using. I'm not sure what you mean, Sanchit. Do you mean like programmatically? Oh, sorry. How to identify which Android? Off the top of my head, it's been a while since I did this. Let's go to an activity. Oh, that's not what I wanted. Give me an activity. Dang it. So if I recall correctly, you can use annotations at, what is it, version? Maybe someone in the chat can help me. It's just been a long time since I did this. OS version, what is the thing? Platform version? Hopefully someone can help me in the chat here. I'm not good at remembering implementation of the version? What the hell is the annotation where you can select for specific versions? JVM, Android. I might have to just look this up. I thought it was like at version. Okay, I gotta just look it up here. Android select version annotation. Oh, Target API. Okay, I was way off. So Target API. And then you can do, okay, sorry. It just took me a little while to find that. So you can do like Target API and then, what was it, build versions Android target API. Or you might not even need that. Is it so? I guess you can just use like build.version.sdk int, and then so we could say like if build.version.sdk int is equals build.version_codes.lollipop. So this is one approach you could use. Why is that showing? Oh, SDK int. So this is one approach you can use, something like this. And you can use that as conditional logic to check for specific versions of Android and adjust your code accordingly. Okay. Oh, only programming has a technical question. I'm not sure I can answer that. It's been a little while since I messed around with JSON serialization. I've been using protocol buffers lately. Like this application, I know I'm not answering your question, but this application here actually uses, where the hell is it? Protocol buffers, which is kind of similar to JSON. It's been a while since I messed around with JSON. So the question was how to serialize or convert JSON file to model class. Start with random number, some things like that. I don't, off the top of my head, I can't really help you with that. Unfortunately for me, if I don't work with something, if I haven't worked with something recently, I tend to forget how to implement it, which is why it took me forever to remember the target API thing. So I can't really help you with that. Sorry, man. Let's see. Oh, I can definitely help you with this, Sultan. Sultan asks, what's your approach to learn algorithms? Boy, do I have a learning resource for you, my friend. Okay, Sultan, here's my suggestion. I wrote an article for Free Code Camp, and it's pretty popular. So, let me make sure I'm not in full screen mode. Okay, so I don't really teach stuff typically like most people do. What you're going to get in this article, if you choose to read it, it's free, is I'm going to, for you, condense basically a year and a half, 16 months of my own study in software engineering, which is basically the field where algorithms and data structures is formally studied, in one article. It's not going to be an easy article to get through, but understand I'm condensing literally like a year and a half of knowledge and practice into one article. And what I do is I explain to you the motivations behind these things. So in order to really grasp what data structures and algorithms is about, the first thing you need to understand is, why do we even do that? And I'm not going to give you the full lesson here because it would take forever, but the very first piece of the puzzle, see up here we have Lego blocks? I'm giving you the individual pieces and fitting them together for you as in the best way I can. So the first thing you need to understand is that a computer, the computer you're using, has runtime and it has memory space. And so the whole purpose of software architecture, let me write this down. The whole purpose of software, sorry, I said software architecture, I meant engineering, my bad. The whole purpose of software engineering is to make your code more efficient with respect, so like concerning runtime and memory space. How much memory it consumes, how quickly it executes. So once you figure that out, what I do, this is the most important thing. We start here, and I'm trying to hopefully give you some pointers here. First, you want to answer that question. Why do we care? What is the study of software architecture, which is the study of algorithms and data structures, among other things? First, we need to know, why do we even bother? Second, we ask the question, how do we know if one algorithm is more efficient than another? And then I explain this using graphics, and I try to explain it as simply as possible. Some code you write will operate in a fixed time period. Some code you write will take exactly as long to execute as the number of elements in that code. So if I pass in an array, if I print an array, then the time it will take for that code to execute will be proportionate to the size of that array, and that's what n represents. And then some code we write, as the array gets larger, for example, it doesn't have to be an array, but that's an easy way to explain it, our code gets really crappy. And when you're working on an application like Facebook, because the size of the data is so huge, if you write crappy code in an application which works with giant data sets, then your code can rapidly become unusably bad. So, whereas if you learn about software architecture, or sorry, software engineering principles, you can learn how to write code which, if I can find the graphic, as the size of the data set increases, the code becomes more efficient. So, this article will explain to you the motivations, how we measure efficiency. It'll explain what an algorithm is, and it'll explain what data structures are. And this is the best resource I can give you to learn these topics, because to be perfectly honest, I don't know anyone who teaches these topics like I do. I'm not saying I'm the best at teaching them, but the overwhelming majority of learning resources I looked up for learning data structures and algorithms were so boring and dry and technical, and they never explained what the purpose was. Why do I care about this? What they did is they said, here's how to write a binary search. Here's how to write merge sort. They gave it like a laundry list of topics, and maybe if you're lucky, they kind of gave you some hints about where you should use one or the other. So that's my main suggestion. And then the other suggestion is write code. When I wanted to learn data structures and algorithms, let me pull up a sample code here to demonstrate what I did. I don't think I can, sorry, but I wrote a repository which had all these different data structures, and I implemented them. That is, I wrote them in code to learn them, instead of like learning from courses and stuff. I did take some, or look at some MIT lectures on data structures, in particular algorithms actually, like merge sort and quicksort and that, but even those I found pretty difficult to absorb. I learned the most by building these things. Okay, moving on. Okay. Hopefully that answered your question. From Jacob asks, after a while, all coding and programming tasks become mundane after a learning phase. How do you manage to keep excited? So I'm actually going to give you some psychological things to consider here. So and understand, I'm speaking from direct experience. So this is almost like I'm giving advice to myself in the past. I'm not sure if you're older or younger, but so I was addicted and still am to novelty. So new things, new learning tasks. And this is a feature of the way my brain works. I have a very addictive personality, a very obsessive personality, and I get a kick. Problem solving is my drug. Solving difficult problems was the first thing in my life where all the crap I was dealing with in my awful upbringing just fell away, and then I could just focus on solving a problem in code, for example. So even though I wasn't good at programming when I started, I was good at problem solving, and that's why I ended up in programming, essentially. That's a long story, but yeah. So the thing about it is that I suggest you look at this from like a psychological perspective. So if you enjoy learning and problem solving, then and you use that as your only motivation, excitement is a great way of talking about it, then you're going to run into problems. This is a very important point. Let me summarize one of the most important things you can ever learn about cognition, which is the topic of learning. Interest. Interest is directly tied to cognition, which is a fancy word for learning, and motivation. So really what I'm going to flip this question around. So how do I work on programming tasks if I am not particularly interested in working on them? This is kind of, if I'm reading you correctly, at least speaking from my personal experience, this is really what I'm asking. What we're asking here. How do I work on programming tasks even if I'm not particularly interested in working on them? Well, here is my suggestion, and this is going to be easy to say but difficult to do, and it can be summarized by something which was said about 2,500 years ago by a very, very intelligent person from India, although at the time it wasn't called India. A happy mind is a mind that is ready to do work. So what I'm saying here is that if you're have an addicted, stimulus-addicted mind, then you're going to be unhappy unless you're being given novelty. Whereas, if you do things to make your mind happy before your work periods, your mind will not be in a stimulus-addicted state. It will be happy, and then it will be comfortable doing whatever it needs to do. Now, that's very easy to say, but it's taken me probably about 7 years to figure out some reliable ways to do this. You're probably going to hate my answers here, but I'm going to tell you what works for me, not what I think you want to hear, which is what a lot of people will tell you. They'll give you, top 3 tips to maximize productivity. I don't do that. I speak the truth. I tell you what worked for me from my personal experience. Exercise, meditation, watching my diet carefully, doing the things I am least interested in doing when my mind is the least distracted. So for example, in the morning, for me, although I recognize some people are the least distracted at like midnight or whatever, I'm not that person, but that might be what works for you. So exercise and meditation, what do? They affect your brain. They make you happier. A happy mind isn't looking for stimulus. It's not looking for novelty. It doesn't need that to feel happy. An unhappy, bored mind needs it needs something. Make me happy. I need to work on something interesting. So that's kind of how I want to answer this question. You need to look at it as a mechanical problem. Mechanical problem instead of trying to solve it using hacks or whatever. A happy mind is a mind that's ready to do work. When your mind is actually happy, and me as a young adult, my mind was unhappy most of the time, so it was really hard for me to motivate myself unless I had some kind of novelty. This is really what I suggest to you, and hopefully that's useful. It might not be, but I did my best. All right. Wow, that sucks. Anyways, let's see. I guess I'm not sure if Sanchit is asking me to make a Netflix app using AWS, but I'm not, again, much to my detriment as a content creator. I don't just copy other people's applications and build fake clones of apps. I'm not saying that's a bad thing to do. I like to build my own apps and teach you how to build the apps that I build. So if I do use an app which uses AWS and video streaming in the future, then I'll probably teach something like that. Thank you, Rendezvous. I appreciate that. Lucas asked, do I recommend to learn dynamic programming, especially for Android developer? So because I suck at jargon, I don't actually know what dynamic programming means, but I'm going to look it up and I'll tell you if it's something I actually do in code. Huh. Interesting. I don't know. I'd have to look at it for a while. So in my in this application, so I have this big, Sudoku builder. What's it called? Build Sudoku. I have this giant algorithm which generates the Sudoku puzzle, and then I broke that down into a series of sub-problems, and I benchmarked each of them to see how efficient they were. I don't know what dynamic program means specifically. Maybe it's something more specific than that. But I'm inclined to say I don't think beginners would need to know that. I think a beginner should be most concerned about writing decent, loosely coupled code, but probably it's not a bad thing to study. Yeah. I probably apply dynamic programming, but not like deliberately. My friend Vivek. Ryan, can you help me out? Sometimes I just focus on results too much, whether I will achieve it or not, something like that. What to do then? Well, my friend, this actually ties into what I said before about the addiction. Because when you get the result you're looking for, you get like a kick. You get like a good feeling. What works for me is, so let me Let's try this. I apologize, my hands shake because I was born with hand tremors. So I'm just showing you up on one of my cupboards here. Oh, I'm not even sure if that's visible. I have a weekly schedule. Sorry, I don't know if anyone can even see that, but what's on here is the days Monday through Saturday. Sorry, Monday through Sunday. And you'll see like 6, 6, 6 and a quarter, 5.5, 6 and a quarter, 5, 5. Then we've got for this week 6, 6, 5, 5.5, 3. Yesterday was 9.5 hours. So let me explain how that relates to this question after I try desperately to fix my webcam. But I really shouldn't have done that. Okay, hopefully the angle's all right. So what exactly is that up there? So I had the same problem, Vivek. I grew up in a life situation where I was very unstructured and lazy, essentially. That's what I was taught. And when I moved out, I started to learn about productivity and goal setting and time management. And I really forced myself to internalize the idea that I need to work hard every day. And that was useful, but I realize in retrospect, like you mentioned here, I was too focused on the results. And now, some of the younger people hearing this, you're probably thinking, what else should you be focused on? Should you not work hard? And that's not it at all. Here's my suggestion for people with that. The thing which determines a successful work day / study period / whatever is not whether or isn't is not sorry, I'm failing at English here for a moment. The thing which determines a successful workday / study period / whatever is not whether or not you get the result or achieve your goal. It is if you put the time in. So that thing I showed everybody before, which probably wasn't even visible, is how I track my time. So I do have a schedule. I do follow a schedule. And I do have goals. I do write down my goals. But one thing I have had to train myself to do, because I had that same problem, I would work for 8 hours, and if I didn't manage to solve the problem, I would be pissed off. Nowadays, if I work for 8 hours, if I put 8 hours of effort into solving that problem, that is a damn good work day. Because, here's why. And this is from ancients. This is from a Roman emperor. This is from an ancient Indian, Siddhartha Gautama. Very simply put. Oh God, I just forgot exactly what I was going to say. Okay, here's what it is. Worry about what you can control, not what you can't control. So how does this manifest in what we're talking about here? You can make time and effort to solve problems. You can control that. You can, to a large degree, say to yourself, although sometimes if we're depressed or something, that can be difficult, but for the most part, you can decide to put 6 hours in every day or whatever works for you. You cannot know how long it will take to get the results. So we see this so much. Let me take a great example. Has anyone heard of Fallout 76? So Fallout 76 is like the 5th or something game in the Fallout series. And so Fallout 76 is an MMO by Bethesda, and it was quite probably one of the worst video game launches in history. Here's a quote from, or a paraphrase from Todd Howard, the like lead designer for it. This is a paraphrase, not a quote. It wasn't much that we didn't screw up. That's a paraphrase, but he basically said this. There wasn't much that we didn't screw up, looking at it after the fact. So the question is, why did one of the most successful game companies in history completely blow it with a game? Because they had a timeline, like an expected timeline, and it turned out that they were some combination of understaffed and greatly overestimated the time it would take to build and test this application, or this program, or this game. Sorry, I'm used to programming. I mean, it is a program, but yeah. So this is really just to illustrate the big screw up by Bethesda with this game is they set an unrealistic time frame, and the truth about anyone who's been a software developer, you should know this. What's an example in my app here? Yeah, Cyberpunk is another great example. It took me a couple days just to build this timer widget here. Why? Isn't that a really simple thing to do? Well, the reason why it took me a couple days to build a timer is because first I tried Android's chronometer class. It did not play nice with Jetpack Compose. It did not work the way I wanted it to. Then I tried Java's timer class, and it behaved the way I wanted it to. However, because it was a multi-threaded, or a threaded mechanism, and Compose makes use of its own threads, it was causing concurrency problems, race conditions, and it was crashing the application. Finally, after trying a lot of stuff, I eventually figured out how to just use a very simple coroutine based timer and to use that instead, and this thing works beautifully. So, that's a perfect example. If I said to myself, my goal is to build a timer, and I took, 3 days to build that thing, I would look at myself and say, it took me that long just to build a timer? I suck. Instead, what I did, and this allowed me to keep working on it, is every day that I spent, I said to myself, good job, Ryan. You sat down and you tried to solve this problem. And that's what you want to go for. When you sit down and put the effort in, it does not matter how far you get. It matters that you put the effort in. And when you do put in your effort, you need to tell yourself, you need to give yourself positive feedback. And that's what works for me. Because like I say, every software developer who spent some time as a software developer understands you can't predict how long things are going to take most of the time, a lot of the time. You can control how much effort you put in. Hopefully that was a useful set of rambling. Okay. Jacob asks about non-fungible tokens. That's an interesting topic. I did actually learn about cryptocurrency a little bit lately, but I haven't looked into non-fungible tokens. I'm assuming that they'll use a similar blockchain style. There's probably some transactional component which allows them to be non-fungible, but I'm not an expert in them, so I won't comment further. Hey, Vladan Yavanovich, what's up? Thank you for stopping by. I gotta repeat the comment because it's a very nice comment. Vladan asks, long time no see, like 3 years, just passing by and wanted to say hello and keep up the good work since my first steps in Android development started with this channel. Uh, Vlad, thank you for taking the time to say that because it does mean a lot to me when people say that kind of thing. All right. Hakeem, this is a technical question. Oh wow, I've been going for 2.25 hours. Well, screw it, let's just keep going. Hakeem asks, hi Ryan, do you think REST is necessary for Firebase reads and writes? You can use the Firebase for lack of a better term, just the API. So Firebase, you can use their REST API, but you can use their the Android API, which basically what this basically means is that the builders of this API will make the REST calls for you. I don't have a recent project which demonstrates this. Let me pull up Space Notes. Okay, so this is a large multi-module project that I put together, which uses a whole bunch. It's super clean architecture, basically, but in the backend module, I use Firebase. And let's go to Note, registered. And so what you can do, it's been 2 years since I did this, so I'm assuming you can still do this. But if you use like the Firestore API from whatever Firestore, then you can use these query things to ask the Firestore for data, or you can do the writes. So where's a write? Here's a delete. Here's an update. So you can just update the collection. And what I ended up doing in this app is I wrote my own my own coroutine extension function, which wraps these calls. And I'll just show you really quickly where that is. That'll be in data extensions. So I just have these extension functions which await the asynchronous callbacks that you get from the Firebase API, and then it just spits them out. So to answer your question, yes. So REST is not necessary. You can use it. It just depends. It might be better to use REST if you want to get hired, but some companies will just use the API, so I can't even say that for sure. So Jacob comments, I disagree with not being result oriented. Day-to-day goals is fine. You may achieve them or not, doesn't matter. But every day, whatever you do should get closer to whatever goal you want in life. So I think you misunderstood what I said here, Jacob. I didn't say don't be results oriented. I did say work on your goals every day. So I think you might have misinterpreted what I said there. I'm saying put time in every day, but don't care how quickly you get to the results. And if you think you can do better than that, then I respectfully disagree. But I think you might have understood that a little bit. I'm not saying don't be results oriented. That's not what I'm saying. I'm saying don't tie your self-esteem to goals which you may either not be able to achieve or might take a whole lot longer, because if you do that, then you're going to be unhappy until you achieve the goal. Whereas if you are happy just putting the effort in each day, you'll be happy each day. So that's what I'm saying here. I'm not saying don't be goal oriented. I have goals and all that stuff. Let's see. Yeah, rendezvous just on the timer. Rendezvous comments, so true. I'm having problems implementing timer. First, rendezvous is using the timer class and then the chronometer, but I want to work in the background. Yeah, this is exactly the problem. So oh, it's okay, Jacob. It's no problem. And thank you for commenting. It's important to have a dialogue here. That's the whole point of this show. Yeah, I worked with the chronometer first, and then I don't think the chronometer is a background. And then when I was working with the Java timer class, because it uses its own background thread, it was not playing nicely with Jetpack Compose. Because in Jetpack Compose, under the hood, there's some coroutine magic and some small degree of multi-threading going on. Although I'm not saying that coroutines are multi-threading. That would be wrong, because coroutines are not threads. They just share some characteristics. Okay, I think I'll stick around for maybe one more question, and then I'm going to call it a day. But wow, that 2.5 hours or whatever out here flew by. At least for me. Maybe it was boring and awful for you. Oh, I need some water. So, any final questions or comments from the chat? Oh. Uh-oh. You guys can see underneath my backdrop. All right, well, I'll just wait a moment longer, and then I will do my outro. Akeem says, thanks for a lot of great content. You're very welcome. I'm glad it's useful. It's too bad the YouTube algorithm doesn't think that my content is very good, but that's okay. Jacob comments, good session. Learned a lot about mental well-being. Honestly, like that's oh no, the Apache just showed up. Well, thanks for stopping by anyways. You know, mental well-being is sort of the underpinning of productivity. And so it's something that I've been exploring myself for nearly a decade. So Abhishek says I am underrated. Yeah. I just suck at like the YouTube algorithm. Yep. You know, at the end of the day, though, I realized, this is something I've known for years. There are people out there who are really great at making popular YouTube videos, who give people really bad advice, and you probably know who I'm talking about. There's two main people in my space who fit under that category. And in case you're confused or assuming things, I'm not talking about coding and flow. I like Florian and I like what he does. But there are some people more popular than him who give really bad advice. And the honest truth is that when I die, I want to be remembered as the guy who gave people really good advice. Not the guy who was really popular. Because at the end of the day, I sleep very well at night. In, you know, knowing that I'm not popular, but I help a lot of people. Nice, Hakeem. Your words, not mine. What's up, Ivan? Yep. You know what it is. All right, thanks everybody. I can't talk because I'm so tired. I'm going to call it a day. That was a 2.5 hour live stream, which is, well, it's not quite the same as my 10 hour and 50 minute live stream that I did once, and y'all should check that out. I actually basically built an entire application in 10 hours and 50 minutes in one sitting. Yeah, 2.5 hours is pretty good. Thank you so much for watching, everybody. I had a lot of fun today. I hope you all had a lot of fun. Let's remember, don't be dogmatic about architectures or platforms or technologies. Use what works for you. And what the hell? Google censored Rendezvous because Rendezvous said likes and subs, guys and gals. Thank you, sorry, I said Google, YouTube comment algorithm for preventing people from helping me build my business. Holy crap, I hate YouTube. Anyways, thank you all for watching. I hope you all have a great Sunday or whatever it is for you. And happy coding. I'll see you next weekend. Peace out, my cousins.